Hello, I am Anupam Monsi Thomas of S8 ECE and I am going to be presenting a seminar on the topic RedTacton Technology. I'm guided by Professor Sanjay Sebastian and my mentors are so um, Professor Anto Manuel and Dr. Arun Sir. So today I'll be going through the following contents. I'll be going through the origin of RedTacton Technology, what exactly is RedTacton Technology, the near-body electric field communication that's involved in RedTacton, basic principle on which it works, and overall uh, look into the working of the RedTacton technology, a block diagram of a basic RedTacton transceiver, features involved, comparison with other technologies, human safety, because this is an inter-body communication technology, prototypes that are currently available or that are in development, challenges that are being faced by this technology for its development, applications that are possible, and references will be shown out of which the whole presentation has been made. So, Tacton is a technology that comes from human area networking. Human area networking is an innovative technology that uses human body as a data transmission vessel for communication. So, RedTacton basically is a name that is derived and means and coincides with red want, detach, and action. Act on for action stands for RedTacton. Now, the human area networking technology was first developed in IBS labs by TJ Simmel, and later it was developed by an entity in Japan for further developments. So how this goes is like, so interbody communication is the key concept of RedTacton. This concept of communication was primarily proposed by IBM in 1996. IBM started that with the small, minute electric fields present in the human body and explained how these electric fields can be used for the transfer of data. T.J. Zimmerman was the first person to study the use of this electric field as a medium of transmission of data through human body. He worked with IBM. He demonstrated human body as a signal carrier between components and proposed electric field technology using AC electric field at a range of 0.1 to 1 MHz and created a prototype that could transmit the data up to 330 kHz speed. He kept the frequency range between 0.1 to 1 MHz. Because of this range, noise within the environment attenuated the frequency spectrum range and speed for data transmission was decreased. Therefore, he stopped further developments in this technology. So, we found out two drawbacks within the existing system. The range of communication was only within a few centimeters and data was transmitted only with a speed of 40 bits per second. So the above drawbacks were reduced by Nippon Telegraph and Telephone Corporation, or otherwise known as NTT, in Tokyo, Japan. They made use of photovoltaic cells. Photovoltaic cells are basically clean source of energy. NTT company used these cells to increase the voltage of minute electricity of around 0.4 to 4.4 to 6 volt. Photonic electric field sensors played an important role in RedTacton, and after comparing the data transmitted data at a speed of about 10 Mbps, NTT company used these important features to fabricate interbody communication receiver operation for its hand technology. Communication was possible through any part of the body, that is legs, hand, feet, trunk, etc. It was discussed around the period of 2002 and was released in year 2005. So we are going to the next slide, which is basically what is RedTacton. As discussed earlier, RedTacton makes use of the body's weak electric field and transmits data at a speed of about 10 Mbps. Since the technology has been proved provide human body as a safe medium for transmission, and it uses a chip and has a transmitter and receiver, so a transceiver system is also there. And near body electric field communication. So the Tacton, as mentioned, revolves around near body electric field communication. The transmitter uh, uses an AC electric field signal which is modulated by the input data from the electrode. Receiver is another electrode that is used to read the weak AC electric fields on the body induced by a signal. This demodulates the recovered data. Transmitter and receiver capacitively are coupled to the body through flat electrodes. So basically, uh, transmitter and receiver are capacitively coupled. Near body electric field is modulated. A feature of the technology is that because signal is passed to and from the body surface through this capacitive coupling, it can be transmitted between transmitter and receiver via the body surface. If this technology is applied to an entry control system or ticket gate, it is much more convenient than conventional contactless cards because you do not need to remove the access card from your pocket. Now, the key aspect of this technology is the behavior of the AC electric field, which can be summarized in terms of three components produced around the body when an AC signal is applied to a parallel plate electrode attached to the body. These components, which are all related to the distance r from the body, are quasi-static electric field, which is proportional to 1 by r raised to 3. Then there is induced electric field, which is proportional to 1 by r raised to 2. And then there is emitted electric field, which is proportional to 1 by r. Our near body electric field communication technology uses quasi-static electric field, which attenuates deeply with r, and we can say that it suppresses both the induced and radiated field components. To suppress these emissions, we use a low frequency to drive the transmitter electrode, higher receiver sensitivity, and the minimum required power for the transmitter. From the beginning, we were aware of the above-mentioned technical background, so we selected the frequency band from 5 to 10 MHz and developed ways of modulating the near-body electric field efficiently and reducing ambient noise such as electrical hum in the receiver circuits. This enabled us to develop a near-body quasi-static electric field communication technology capable of providing the quality required for communications services while using a minimum level of power in the transmitter. We selected this frequency range to avoid the strong environmental noise below 1 MHz and to control electric field emissions from the human body and the transmitter electrodes. We have confirmed that the actual electric field produced by our prototype transmitter is an order of magnitude smaller than regulation levels for short-range wireless schemes. So this is the picture that discusses the electric field and capacity coupling models of near-body electric field communication. As we have already discussed, the transmitter and receiver are coupled to the body, and other features of this technology is that it suppresses the emission of electric field from the body into space. Mutual interference is reduced. It enables intuitive connection through touch communication, and signal propagates over the bodily surface. When transmission signal is strong, a stronger electric field is emitted around the body, reducing differentiation from short-range wireless technologies. Now we will discuss the basic principle about RedTacton technology. The basic principle of RedTacton technology is that it relies upon the principle that the optical properties of an electro-optic crystals can vary according to the changes of a weak electric field. So we have already mentioned transmitter has a photovoltaic or electro-optic crystal, and its optical properties change when it comes in contact with the weak electric field of the human body. And when these changes in the optical properties are detected in the electro-optic crystal using a laser, the result is it converts the results into an electric signal in an optical receiver circuit. The receiver circuit converts the result into an electric signal. So now we will discuss the mechanism and working of RedTacton device over the surface of our body. This is the diagram we have shown previously is the reference diagram. So it has a transmitter and a receiver. Transmitter induces mild electric field on human body, and photonic electric field sensor or optical properties senses the electric field, and as a result, this sensor detects the field, and the data is processed and is downloaded. Data is received using a photonic electric field sensor that combines an electro-optic crystal and a laser light to detect fluctuations in the minute electric field. The naturally occurring electric field induced on the surface of the human body dissipates into the earth. Therefore, this electric field is exceptionally faint and unstable. The photonic electric field sensor developed by NTT enables weak electric fields to be measured by detecting changes in the optical properties of an electro-optic crystal with a laser beam. So this shows a person opening a door with the help of a RedTacton device. They have a transmitter and a receiver or a RedTacton prototype in their hand as well as attached to the door, and when this comes in contact, the human body acts as the transmission medium and the door is unlocked. The figure below shows the block diagram of a RedTacton transceiver. The signal from the interface is sent to the data sync circuit and the transmitter circuit. The data sync circuit senses the signal, and if the data is present, it sends control signals to the transmitter, which activates the transmitter circuit. The transmitter circuit varies the electric field on the surface of our body. This change in the electric field is detected by the electro-optic sensor that is present in the receiver module. The output of the electro-optic sensor is given to the detector circuit, which in turn is given to the interface of the receiver RedTacton device. So that is about the block diagram of the RedTacton device. Now we will be discussing about the features of RedTacton technology. There are basically three features. There is touch feature, there is a broadband and interactive feature, and there is the any media feature. Touch feature revolves around communication with just a touch or a step. Broadband revolves around bandwidth, and it does not deteriorate even with duplex operations and simultaneous access, and it works basically in AD media. So the touch feature. The communication path can be created with a simple touch, automatically initiating the flow of data between a body-centric electronic device and a computer that is embedded in the environment. For example, two people equipped with a RedTacton device could exchange data just by shaking hands. A wide range of natural human actions, grasping, sitting down, walking, or standing in a particular place can be used to trigger RedTacton to start a network process. So basically actions like touching, gripping, sitting, walking, stepping, and other human movements can be the triggers for unlocking or locking, starting or stopping, or connecting and disconnecting the equipment, or obtaining data. Now broadband and interactive. Using a RedTacton electro-optic sensor, two-way communication is supported between any 2 points on the body to a throughput of up to 10 Mbps. Communication is not just confined to the surface of the body, but can travel through the user's clothes to a RedTacton device in a pocket, or through shoes to communicate with a RedTacton device embedded in the floor. Unlike wireless technologies, the transmission speed does not deteriorate even in the presence of large crowds of people, all communicating at the same time in meeting rooms, auditoriums, stores, etc. So compared to other technologies, the transmission speed does not deteriorate like that of Bluetooth and Wi-Fi. Because the body surface is the transmission path, increasing the number of connected users directly increases the available number of individual channels. So UPS interactive communication is possible at a maximum speed of 10 Mbps. Transmission speed is on the surface of the body, and as a reason, transmission speed does not deteriorate in congested areas where many people are communicating. It only gets strengthened. Now the last feature is how it works with almost any media. RedTacton can utilize a wide range of materials as a transmission medium as long as the material is conductive and dielectric, which includes water, other liquids, various metals, certain plastics, glass, etc. Using ordinary structures such as cables and walls uh, that are familiar and readily available, one could easily construct a seamless communication environment at very low cost using RedTacton. And in addition to human bodies, various conductors and dielectrics can be used. Uh, they may be of any combination. Any type of media, metal, water, can allow the flow of the signal. Now we will discuss. So we already discussed the features. Now we will discuss what makes RedTacton different. So we are comparing RedTacton with Bluetooth and Wi-Fi. The major factor in RedTacton is that it uh, major factor that makes it unique is the security that is offered by RedTacton device. That is much lesser compared. That is much higher compared to Bluetooth and Wi-Fi. Uh, we will get to comparison using the following charts. Uh, in the below chart, uh, it shows the positioning of RedTacton with respect to existing communication technologies. The focus is on ubiquitous service, and this has brought about the shortening of distance in communication. RedTacton is positioned as the last 1-meter solution to ultimate close-range communication. Wireless communication creates connections when signals arrive, allowing for easy connections because connectors are unnecessary. However, seen from another perspective, the arriving signals can be intercepted, so security becomes an issue. Wired communication transmits data between two connection points, so interception is difficult and security can be considered to be high. However, connectors and cables are a nuisance. Taking the above points into account, RedTacton is situated directly between wireless and wired communication. RedTacton allows for easy connection without connectors, while at the same time allowing transmission of data only between two contact points. It thus has the feature of being difficult to intercept. Uh, Interbody communication using the human body as a transmission medium have been reported, but electric field photonics method employed by RedTacton is superior to conventional methods in terms of communication distance, speed, and interactivity. Advantages of it over Bluetooth include the system that was envisioned by NDT utilizes a conversion method which takes digital data into a stream of low-power digital pulses. These can be easily transmitted and read back through the human electric field. While it is true that similar personal area networks are already accessible by using radio-based technologies like Wi-Fi, Bluetooth, this new wireless technology claims to be able to send data over the human skin surface at transfer speeds of up to 10 Mbps, or better than a broadband TI connection. Receiving data with such a system is more complicated because the strength of the pulses sent through the electric field is so low. Uh, Now, RedTacton solves the issue by utilizing a technique called electric field photonics. A laser is passed through an electro-optic crystal which deflects light differently according to the strength of the field across it. These deflections are measured and converted back into electric signals. to retrieve the transmitted data. According to Tom or T.G. Zimmerman, inventor of the IBM personal networking technology, body-based networking is more secure than broadcast systems such as Bluetooth, which have a range of about 10 meters. The issue is that with Bluetooth, it is difficult to rein in the signal and restrict it to the device you are trying to connect to. But in a busy place, there could be hundreds of Bluetooth devices within range. Moreover, body-based networking seems to allow for more natural interchanges of information between humans, as only when you are in true proximity you can make the system work. There are some specific applications that would appear as being ideal matches for RedTacton-like technologies. So as already mentioned, it is a very secure technology compared to Wi-Fi and Bluetooth. And as we have already mentioned as one of its features, it offers maximum strength even when there is a broadband or a network. And now we will also compare the following the charts that were shown. Networking technologies involves the use of data systems to manage and deliver digital resources over a computer network. A variety of industries use this system. RedTacton transceivers are programmable and we know what to share, and it's programmed accordingly. It transmits data with security at the rate of 10 Mbps. Separate channels is available for every communication. It provides secure communication and proper transmission speed for multiple users at the identical time. Slighter data lost. There's only very less data lost during transmission. Least amount of power is employed for the same. Electronic signals radiating from the body are hard to pick up, hence they are highly secure and can hardly be intercepted. Can work using already available software and any conductor. Large marketing applications are there for RedTacton, and if we compare other features, it also includes the following features. Well, it also can only be used on the body surface, not any organ. So now we will discuss about human safety and how RedTacton has no effect on the body surface. For that, we will come to RedTacton has no effect on the body surface. The transmitting and receiving electrons of the RedTacton transmitter are completely covered with an insulating film. RedTacton subject to the radio frequency exposure protection standard or RCR STD38 that is proposed by ARIB. We will further discuss about human safety. The transmitting and receiving electrons are completely covered with insulating film. So the body of the person acting as the transmission medium is completely insulated. This makes it impossible for current to flow into a person's body from the transceiver and does not harm the person's body. When communication occurs, displacement occurs, and displacement current is generated by the electrons in the body because the body is refracting minute electric fields. However, such displacement currents are very common everyday occurrences to which we are all exposed. RedTacton conforms to the Radio Frequency Exposure Protection Standard issued by the Association of Radio Industries and Businesses. Now we will discuss about the prototypes of that has been currently initiated by NTT. NTT has made 3 prototypes and they are PC card transmitted, embedded receiver and USB transceiver. So we will discuss about these prototypes that are currently proposed by NTT and currently developed by them. Uh, the portable card transmitter or the PC card transmitter and a receiver that can be built into environments such as doors or floors are shown in the figure. In the coming figure, the transmission rate is about 230 kbps. Protocol is proprietary protocol and transmission method is unidirectional. It uses frequency range of 5 MHz and binary phase shift keying modulation and achieves transmission speed of 230 kilobytes per second. In some physical applications inducing entry control and ticket gate systems, the transmitter carried in a jacket, vest pocket or trouser pocket transmitting an ID, we achieve communication with a packet error of rate of less than 10 raised to minus 3. The next is an embedded receiver which comes along with it. The transmission rate is also 230 kilobytes per second. It uses proprietary protocol and the transmission method is unidirectional. Uh, then USB transmission, the transmission speed and protocols haven't been determined as it is still in the testing stage. The challenges that are involved in RedTacton technology is the cost and time of development, it not being popular enough, and proximity issues that are associated with RedTacton technology. So, if we discuss about this particular topic, uh, we'll have to discuss why RedTacton technology is not yet popular. Each module that is involved in the transceiver and receiver, which includes electro-optic crystal and things like that, require a huge cost, and also the development of a single prototype requires a lot of time. Since this is an intra-body communication, people would have to be convinced about the safety of the device that is being bought by them, and since the development time and cost is very big, uh, initially the device could only be sold at a premium cost, and to find an audience that would buy the device at such a cost, such a premium cost with the existing technologies that are very similar like Bluetooth and Wi-Fi will be a very tricky task. Also, there are proximity issues associated as data is transmitted at about a range of 10 meters, and while there are many other technologies that are being transmitted at a higher uh, proximity. So, we will now discuss about the applications of RedTacton. We'll majorly discuss about two fields of application. There is the medical field, and then there is also the military field. So first we can discuss about the medical field. Medical field, there are about two applications we can uh, apply it to discuss or to measure various uh, levels of blood sugar or temperature, etc. in the human body, and using this we can employ correct medication. One critical success factor of this technology in medical application is it must work or it could create a live or death situation. If a death occurs that was caused by the technology not working properly, the negative publicity and paternity suit will force the technology to be deserted for a medical application, however. Another critical success parameter is that the cost must not exceed the business provided by the technology. So, how the technology helps is that um, it can be used to check blood insulin level. The device can be used to measure if there is a surge or there is a drop in insulin, and immediately this information can be passed on to the caregiver through another Tacton transceiver device, and the correct medication can be applied to the patient without any delay. Another application is in military area for weapon security and body misuse. In gun, during the war, A soldier having a RedTacton authenticated gun is supposed to fire with that respective gun only. No other soldier can use that gun for firing, and if that authenticated soldier is dead or not able to participate in the war, it gives advantage that the enemy soldier cannot attack using that same gun, or they can't use the other party's ammunitions. Black marketing of guns can also be reduced to a large extent using RedTacton technology. Then automatic access log files kept securely in the computer or at other data storage is also sometimes prone to vulnerable attacks. Use of these technology will provide security and authentication of their log files, and hence data will remain confidential. So that is how it will help in the military field. Also, the critical success factor is that it must work or it will be inhabited for, and then it will be inhabited for gun security. This technology must provide the security that it is designed to provide. For example, the enemy or black marketers can't replicate the transceiver of defense program, the transceivers for their use. Uh, they have to use the benefit of the security, and they have to have faith in it and trust that it will work in all situations. For the technology to be adopted by the population worldwide, or for US population where gun control is a very huge thing, there will need to be a low cost that requires the technology. It is possible even without a law. A painstaking gun owner would elect to have the RedTacton technology installed on their gun to prevent a child or stranger from using the gun and avoiding mass attacks. The price of RedTacton technology would need to be competitive for this to be possible. It can also be used for other consumer application, and it can be used in other devices, other touch devices. Um, that is already proposed by NTT. Uh, it can be used in an alarm, as in when a customer in medical stores touches a wrong bottle of medicine which is not prescribed to them, then the alarm starts triggering from the bottle. This triggering is possible because of the RedTacton device present inside the bottle. The alarm triggers only when the user touches the bottle, reducing the false alarm, which can be triggered from the proximity. When they validate, and it can be used in advertising panel as well. When the validated user within the company premises just stands in front of the advertising panel, their full information is displayed. This provides security from other common unauthorized party who enters the company. So RedTacton is a fascinating new technology for human area. It uses the unique electric field that outperforms previous approaches in terms of communication range, data transfer rate, and how interactive it is. It cannot be hacked, and it is extremely secure, as RedTacton uses a property of photonic electro-optic crystal. It has advantage over other technologies in terms of communication distance, transfer rate, and interaction. Most importantly, the data transferred through this technology cannot be hacked. A very big achievement is obtained in the field of medical application security applications with the help of invention of RedTacton technology. If RedTacton is introduced in the world of cyber market, it will bring tremendous revolution as much of the cyber crime will be eliminated. There are no dangers to the human body from the electric signal and other radiations created by this technology, because human electric field is the medium to transfer the data. No other technology can replace the Tacton, and also uh, the need for artificial implants to communicate with each other as well as to report back to a portable device could have quite some value. In fact, according to other researchers, the most important application for body-based networking may well be for these type of communications. RedTacton Technology is expected to compete with Bluetooth and Wi-Fi in the future. It could put the use of cables to an end. The problem faced by RedTacton is, however, the cost of development. It brings a new dimension of communication which effectively links the user to anyone they want to communicate. Since it provides high-speed communication, it can provide seamless service wherever, whenever, and whoever uses it. So these are the references that were used from the initial Taction Technology, International Journal of Engineering and Advanced Technology. I derived the basic principle as well as what the definition of RedTacton technology and its working. From touch and transfer using RedTacton, I derived some concepts of comparison. From concept, again, I derived the advantages, the disadvantages, the principle. From future belongs to RedTacton, I derived some of the applications. And from the contiguous potential of RedTacton's already, I derived the comparisons. From security enhancements also, this I derived about the human safety of RedTacton technology. From the seventh paper, I derived uh, and explained about the concept of near-body electric field communication technology. And from the eighth paper, I derived the applications. Ninth paper, again, further discussions and charts on comparison of RedTacton with Bluetooth and Wi-Fi. And these are the links from which the pictures that were utilized in the slide was used. Thank you, and I hope everyone got an understanding of the topic. Thank you.